Hello and welcome to Thursday's edition of Cracking the Cryptic. And on screen we have a puzzle by Prasanna Seshadri from India, a brilliant constructor, and this looks very interesting. It has a very unusual rule set. I've not seen a rule set like this before, so I'll tell you about that in a second. A couple of things to mention first. Obviously, THERMO Sudoku, our new app, it's out on Steam, it's out on Android, it's out on App Store. So do have a look at that if you haven't had a chance yet. It's been getting some great reviews to our delight, frankly. Mark and I have been doing a bit of media work the last day or so. So I'm hoping by the time you see this video, Mark's radio interview this morning will be available to listen to on our Twitter account, which is @CrypticCracking. So do go over there and have a listen. He's very nice about our viewers, as he should be, because we think we've got the best viewers in the world. And I, believe it or not, I was on breakfast TV in Chicago this morning on WGN News. So any of you who saw that, I'm not sure if any of you would have seen that, but if you did, do let me know. I'd love to hear from you. And also, we were struck yesterday. There's a podcast called Scriptnotes, which stars Craig Mazin and John August. And Craig Mazin, I know because he wrote the sort of script for Chernobyl, which has been a massive hit here in the UK, I suspect in the States as well. And during this podcast, they have one cool thing that they recommend their viewers to listen to. Now, as you can probably guess, neither Mark nor I has ever been cool in our lives. And, for them to call the Miracle Sudoku their one cool thing was something of a triumph for us. So, we were absolutely delighted with that. And just to mention as well, we hear from a little bird that viewers in the UK who like the channel might want to record Have I Got News For You tomorrow evening. That's all I can say. Do check that out. It's a very funny programme, whether or not there's any relevance to Cracking the Cryptic. Now, let's get on to Prasanna's puzzle. How's this going to work? Well, we've got normal Sudoku rules applying. Killer cages sum to the number given in the cage. Okay, well, that's normal. Little killer clues, that's these clues outside the grid. The way these work is that you have to make sure that along the diagonals, these diagonals would have to sum up to 21. And you can repeat digits along the diagonals. So, if this was a 5, it would be perfectly possible for that to be a 5 as well. Now, here comes the complicated bit. One of the digits from 1 to 9 is a joker. Wherever it appears in the grid, it can count as any digit from 1 to 9 for the purposes of the killer clues and the little killer sums, and it can be a different number in each of those. But it can only appear once in a cage. Well, that's normal. So let's imagine that the number 2 was the joker. Now that would mean that for the purposes of this 21 clue, this 2 could be any number we wanted it to be from 1 to 9. For the purposes of this killer Sudoku box, it could be any number we want it to be from 1 to 9. But what it would mean is that we couldn't put another 2 in there. That's just normal killer Sudoku. You can't repeat a digit in a cage. So that is how this works. I've not seen anything quite like this before. But it's by Prasanna, so it's going to be brilliant. Do have a go. Click on the link under the video to play along. And with that, let's get cracking. Now, okay, well, the 7 clue, that must be important because you can't make 4 digits add up to 7. You could make 3 digits add up to 7 with 1, 2 and 4, but not 4 digits. So the only way this clue can work is if the joker number is included as one of these digits. So, in fact, thinking about it, as the joker has to be at least 1, the other 3 digits have to be 1, 2 and 3. So in fact we know the contents of that box straight away. That is 1, 2 and 3 and a joker. I think I'm going to colour that in actually. I'm going to make blue cells will mean that there's a joker included amongst the cells. So these cells have no joker. I'll make those purple. Now, Oh, 8. 8's got 4 cells as well. Well, that's impossible. You can make 3 cells add up to 8. But again, actually thinking about this, as the joker has to be at least a 1, the other 3 cells have to add up to at most 7. So they could be 1, 2, and 4, or 1, 2, and 3. But they must have a 1 and a 2 in them. And there must be a joker amongst those 4 cells. So again, we can label some cells purple. So, now hang on a minute. This is very interesting already, because several things are occurring to me here. The first is that if we look at this 2x2 arrangement now, which we know includes the joker, but it also includes a real 1, a real 2, and a real 3, because it must do. Therefore, 1, 2, and 3 are not the joker. Now also, as there's a joker in that 2x2 and a joker in this 2x2, where does the joker go in row 3? Well, it must be one of those squares. But these 3 squares also have to include a real 1 and a real 2, because we know there's a 1 and a 2 there and a 1 and a 2 there. So where are we going to put the 1s and the 2s? In row 3, they have to go in those 3 squares. So these 3 squares are the numbers 1 and 2 and the joker. This is crazy. No, it's crazy, but it's brilliant, because now you can't put a 3 in here, can you? If there's a 3 in there, so if this was 1, 2, 3 and a joker, then these 3 squares would have to be 1, 2, 3 and the joker. They would have to be, we'd have to put 4 digits in those 3 squares. So there cannot be a 3 in here. Therefore, there must be a 4. Oh, and also, that's a 28 there. Oh, this is very nice, because this is huge, because if there's a 1 in the 28 cage, then the other 3 cells would have to sum to 27. That's absolutely impossible, even though I could in theory make 2 cells equal 18. You know, I could have 2 9s, because I could have a real 9 and a joker, but I can't have 3 9s. So the 1 must be here, and the 2 must be in here. That's real now. So there must be a 2 in there and a joker. So all these are obviously purple. You can't repeat the joker, so neither of those is a joker. And as one of these cells contains a 2, the other 3 cells have to add up to 26. Now, one of those obviously could be a joker. One of those is a joker, so we could make that 9. So the other 2 cells have to be 8 and 9. They have to be, otherwise you can't get high enough. What a lovely idea. This is just gorgeous so far. Now hang on, because so now I've proved 1, 2, 3 and 4 and 8 and 9 are not the joker. So the joker is a 5, a 6 or a 7. The 33 cage, that's very... Yeah, in fact we've got 2 33 cages. Now you can't get to 33 in 4 cells ordinarily, because 6, 7, 8 and 9 add up to 30. So there is a joker in both of these 2x2 regions. Now, can we do better than that? Yeah, we can, because how do you get to 33, even allowing for a joker? A joker allows you to repeat the 9. That's effectively what it's doing with a big sum, isn't it? So we can get 9 plus 9 plus 8 plus 7 equals 33. That's the only way of doing it. Now that's huge, because now I know there's a real 9 and a real 8 in this 33 cage, and they can't be here because there's an 8, 9 in this box. So these two squares are a real 8, 9. There is a 7 and a joker. So 7 is real. 7 is not the joker. So the joker is 5 or 6 now. And that 8, 9, look, that must be repeated in those two cells, because we know 8 and 9 are real, and therefore they can't go in that 2x2 box. Similarly over here, that's 8 and 9. And this down here is 7, 8, 9 and the joker. Just 1 second while I try and spot. Yeah, I've got something. So there we go. We know the joker is in one of those, so that can't be the joker. So that must be a 2. This must be the joker. It's not a 2, therefore. But we know it's a 4 or a 5 because we know the joker is a 4 or a 5. Oh no, it could be a 6. Sorry, it's not. It's a 5 or a 6. It's not a 4. So now, just wondering where 1 goes in this central box, because all of those squares, actually we can do some more purpling, can't we? I can do a lot more purpling. There must be a joker down there. 1 is a real digit, which sounds a very stupid thing to say, but even for the purposes of this puzzle, it's important. So 1 can't go in there along with the 7, so 1 must be in one of those two squares. Now if the 1 was here, these 3 cells would have to sum up to 26, so you'd have to have 2 9s and an 8, which means a real 9, a real 8, and a joker. Which no, that's not possible, because that would have to therefore be an 8 or a 9, and it can't be. So the 1 can't go in there. The 1 goes there. That's shifts 1s down here. Oh, hang on. We've got an 8, 9 here. I should have spotted this earlier, but look, you can't put a 9 in a 12 cage, because if there's a 9 in there, then the other 3 digits have to be the number 1, and that's impossible. You can repeat 1 digit by using the joker, but you can't repeat a digit twice. So there's no 9 in there, so there is a 9 in one of those 2 cells. Now, can we do the same with the 8? If there's an 8 in there... Oh, that's annoying. No, the 8 could go in the 12 cage, because it could be 8, 1, 2, and then the joker, which could be another 1. Ah! This is tricky. Now... now hang on. Hang on a minute. Just wondering about where 2 goes. Can I put a 2 in this 27 cage? Because if there's a 2 in the 27 cage... Because the 27 cage can't contain a 9. It's impossible for it to contain a 9. The only sort of 9 it could contain is the joker. So if there was a joker and a 2 in the 27 cage... the other 2 cells would have to add up to 18, which is absolutely impossible. There is no way there is a 2 in there. Therefore, there is a 2 in here. And in fact, we know 3 is a real number as well. And where does 3 go in this box? That 3 can't go in here either. Because if there's no 9, 3 and 8 is 11, 16. I get left with 60. Oh, could I repeat 2? Could I get 2 8s in there? Is that possible? Ah. So I go 3 and Joker. Oh, this is doing my head in. So I put a 3 in here. I put a Joker in here to give me a 9. That adds up to 12. I then need 15. But I could have an 8 here. And then I'd need a 7 up here. The biggest digit I could put up here is a 6. So if there's a 3, this is a 3 and a 6. That's a better way of thinking about it, isn't it? If there is a 3 in the 27 cage, it must be accompanied by, at most, a 6. That only gives you 9. The other 2 squares have to be 18. That is a better way of thinking about it. That's impossible, because the Joker could be 9, but the other square down here cannot be a 9. So the 3 does join the 2. Therefore, there's a 2 down there, look. In fact, how on earth do you get to 27 now? Now, so these 2 cells are 2 of the 3 digits 4, 5 and 6. Now we know that from just looking at the fact that there's a 7 pencil marked here and 1, 2, 3, 8, 9 in the box. So, can these 2 squares be 4 and 5? Well, no, because that gives 9 here. That makes these 2 have to add to 18, and we already know that's impossible. So one of these, this is it. One of these has to be a 6, and it has to be a real 6. And therefore, 6 is not the Joker, and therefore 5 is the Joker. And now we are cooking with gas because, well, are we cooking with gas? We get 5s into all of these little 2x2 regions. This now has to be a 4-6 pair to complete the box. This is a 5-7 pair, obviously. Four and 6 add up to 10. These 2 squares have to add up to 17 without using a real 9. So I have to have the Joker in there, because otherwise I just can't do it. So this square is a 5, therefore, I suppose, because 5 is the Joker. That can be a 9 now. This has to be an 8. The 2 shifts downwards. The 8 gives us an 8, 9 here. There must be an 8 up there now. The 8s here and here operate. So there is an 8 in the 12 cage. Ooh, that's huge, because that's got to be accompanied by 1, 2 and the Joker, which is a 5. So we get blue squares there. Look at this. We can do loads of purples, actually. All of those are purples. Now, look. In this 3x3 box, the Joker is in one of those cells, in column 1 and column 2. Same in box 7. So one of these 3 squares, where's the Joker going? In column 3. It must be in one of those 3 squares. So one of those 3 is the Joker. Oh, but we can do better. Look, over this side of the grid, we've got the same pattern, but relating to columns 8 and 9. So we need to put a Joker down here. That's got to be there. That's not a Joker. The Joker is a 5, so let's put it in. All of those squares turn purple. All of these squares turn purple. All of these squares turn purple. We have a very colourful grid. But we only have 9 digits placed. And I've not used the little killer clues at all. I mean, even at this point, I mean, I've only got 9 digits, but you can see there's just too much latitude. We're going to have to use these later to disambiguate pairs and totals, I would think. Oh, now, hang on a minute, look. In this box, I've got 1, 2 and 5. In this box, I've got 1, 2 and 5. So where do the 1, 2 and 5 go in column 3? Well, they've got to go in those 3 squares. But you can't repeat a 2 in this box because it's already got a 2 in it. So the 2 is not there. This is a 2. This is a 1, 5 pair. And that one, well, that's very interesting. Look, and it's forced. We now know this is the joker, therefore it's the 5. That fixes the 5 and the 7, places a 1, puts a 1 over here. Can we get more? We can do a little bit more just with the structure of the 1s in the grid. Look, we've locked 1s into columns 8 and 9 again here. So there must be a 1 down there. Oh, no. Look at this. Look at... Oh. Whoa. Hang on. I just noticed something very interesting about this grid. I noticed 3 things then really quickly. Let me show you. Now, the first thing I noticed was this 2s. The 2s here are aligning in rows 8 and 9. So where does a 2 go? In row 7. Well, it's got to be in one of those 3 squares. I then noticed that the 2s in columns 8 and 9, well, if we look at these 3 squares, the 2 in this box, well, it actually has to be in one of those 4 squares there. So it's aligning. We've fixed some 2s in columns 8 and 9. So it's not possible to have a third 2. If there was a 2 in one of those squares, we'd have 3 2s in columns 8 and 9. Well, that's clearly nonsense. So this becomes a 2. Now the next thing, I actually think I noticed 4 things, because the 1s now align in rows 8 and 9. That places a 1 here, and this got me thinking about Fistemafel and his box pattern. Look at this. Has Prasanna built this into the puzzle? I'm not going to use it for the solve because it's impossible to prove in the video, really. But we have proved it in a video before. I'll try and remember to link that at the end. But what is Fistemafel's trick? Well, these highlighted squares here have to contain the exact same digits as these 16 squares around the edge of the grid. Now, that can be shown to be true as a piece of Sudoku theory. Now, I'm just having a scan now to see whether or not that might be useful. I think it would be useful. For example, you know that one of those squares has got to be a 4 and one of them has got to be a 7, and I've not managed to put a 4 or a 7 in there yet. I'm not going to use it, but isn't that beautiful? Isn't that beautiful? I'd love to know, Prasanna, if you're watching this video, whether or not this was an idea you deliberately built into the puzzle. It's absolutely beautiful. Now, let's carry on anyway. I'm getting ahead of myself. Now look, we've got this going on again with the 3s. There can't be a 3. Well, the 3 here is locked into one of those 6 cells. It's in row 1 or row 2, just as it is here. That square's got to be a 3. Which shouldn't surprise us, because we know that there's a 3 in that 2x2 box, and by Fistemafel... No, look, that's going to give a... If we used Fistemafel, that is a 4-7 pair. So I'm going to label it. I won't use it. Okay, don't let me use it. But I think that is a 4-7 pair. Now it would be fair though if we look along there. I've got 6 digits there, so this has to be 4, 6, and 7. So that would be a fair enough deduction. This being a 4 or a 7, I think looks harder to show, doesn't it? And that would allow me, look, to use a pair there to force these two squares to be 3 and 6. So I'm not going to do it. I'm not going to do that. 3 here, that locks a 3 into one of those two squares. Oh, I'm getting there though. Look, there's a 3 down there now. Okay, I mustn't use that. Don't use that. Let's look somewhere else. What else can we see here? All I can see now is this ring. I've got to just put it out of my brain. 8s, 5s. We've done 5s. Look, I have to change the colour of that. That's not sensible. And got 1s locked down here. 4s. Look at the 4s. There's a 4 in one of those 6 squares. Well, actually one of those 4 squares because of the 4, 6 here. That aligns with the 4s. So these two squares have to be a 1, 4 pair. These two squares now have to be the 3, 6 pair. That forces the 3, 6 pair here by Sudoku, and that does prove the 4, 7, which I suspected was true, but I did it in reverse order using Fistemafel. Now that's got to be 4, 7 and 9. I think we're getting to the point soon where I'm going to have to look at these little killer clues. Now, come on, let's keep it going. What am I meant to see? In fact, looking at this 40 clue, how on earth, this set of cells here is very small. So if I make all of these as big as possible, what do I get? I get 4, 5. I'm not going to count the joker cell yet in case it's a joker. 4, 5, 11, 14, 15, 22. So I have to put 9 in both of those squares. Annoyingly, that one could still be a real 9, I suppose. That doesn't have to be a joker, but that does have to be a joker. So that is a 5. And these squares are real, therefore there's no joker over there. These ones become real. Those ones become real and don't include a 5. And more importantly than that, we can now, this has to be either the joker or a 9. This has to be a 4. I have to go maximal on all of these options. 1 here. 4 is in one of those cells. That has to be a 6. This one has to be a 3. And that one has to be a 7. That gives me a 4 and a 6 there. That gives me a 7 here. And that's obviously pretty helpful. Oh, Alexa's turned herself on.
I can't connect to your Wi-Fi network.
Oh,
you can find setup instructions in the help section of your Alexa app.
Sorry about Alexa interrupting the video. That's a 6, 7 pair there. Now this one as well, look. That's interesting in the opposite way. Because if we look down this diagonal, this is nice because not only do we have so many real digits, because all of these are purple squares, but they are all very large. Well, not all, but several of them have to be 8 or 9. Therefore, I've got to keep everything else down, I would suggest. Let's keep that down. If that's a 1, and that's an 8, and that's a 1, that's 10, 19, 26. That would be 34. I could keep that down to a 3. That's 30. Yeah, that's 37. That's got to be the joker because it's got to be a 1. So this is the joker now, which means that one is a 9. That is lovely. Let's colour all these in. That's a 9. Now that's... I can remove the 5. That creates a 7, 8 pair. Look, the 9 fixes the 9 up here. That fixes the 8 and the 7. That locks a 7 into one of those two squares. The 5 was never in those two squares after we fixed it here. This is a 5 now. That's not 5. Sorry, let me just stare at this for a second. I'm just wondering whether we can do better than this. Well, I need to come back to this diagonal, don't I? So I needed to keep everything as low as possible. So that was a 1. This has to be 8, which fixes this as a 9 and fixes that as an 8. Also places a 9 in one of those two cells. Coming along here, that has to be 8, that has to be 9, that has to be 3, that has to be 6. And that all looks good now. So now this turns purple. This, look, we've got it up here as well. That one must be real. So that's not a 5. This must be a 5. And that's it. We've done all of the jokers. And this 1, look, that locks a 1 into that cell. So that gives, and the 8 and the 2 resolve all that. So that's an 8 and that's a 2. That's a 2 and that's a 3. That must be a 2. 1, 4 up here now. Oh, how can the 4, 9 not get resolved? Come on. Oh, now, hang on. This 21 clue, that's going to be interesting now, because if that's a 9, surely it breaks. Right, let's think about this. If this was a 6, which is the minimum it could be, the minimum this could be would be a 3. So we'd have 6 plus 3 plus 1, that's a joker, so I'll make it small. 10, 12, 13, that could be a 3, 16, this can never be a 9, it breaks. So that is always a 4. That's a 9, therefore. There's a 4 in one of those squares. This has to be 1, 3, or 7. And it has to be a 3, because there's a 1, 7 in the column. So this is a 1, 7 pair which we can resolve. That fixes the 1 and the 4. So 4 in one of those two squares. That's got to be a 2 by Sudoku. And that has to be a 6, I think. 6 gets plonked over there. This is not 2. We need to put... Oh, hang on, not 2, I said. These two squares are a 3, 4 pair which we can resolve. Fixes the 4, of course, as well. That should make that one a 7. That looks good, doesn't it? And finally, we need an 8, which we can also do. So actually, the Sudoku is taking us a long way here. So 4, 6, 7 there. That might be nearly. So 4, 7 here, 4, 6 here. Oh, for this can't be a 9. That can't possibly be a 9. Because again, it's going to break this 21 clue. We'd immediately be on 15, and we'd still have loads of cells left. Yeah, it breaks. So that's the 9. That fixes those two squares down there. Oh, that can't be a 4. I don't know why I've got that penciled in still. These have got to be 6 and 7. You can see the 7 must go downwards. The 6 must go here. That fixes the 6 and the 3. Oh, that's interesting. Look, the 45 clue is already done, even though we haven't actually used it yet. So that's cunning. That's there for symmetry of the structure of the little killer. Look, we've got symmetrical clues. So let's just check I've not boo-booed here. We've got 12, 20... And on the other side, what are the other? Is that right? 12, 20, 29, 34, 5, 44. God, I was having heart palpitations and I thought I'd made a mistake. But that 5 can be a 1 and that is fine. That's going to give me my 45. Okay, so what do I need here? 2 and 9. Yeah, we can do that. 9, 2. Here I still need to place a 4 and a 3. Surely I can do that. No. Oh, okay. So maybe this clue, this 21 clue, is how we disambiguate the last part of this. You can see these 3 squares here have got to be 3, 6 and 7 in some order. That one can't be 6 and that one can't be 7. So we get, let's have a look, we've got 7, 8, 9, 10, 11. So if this is 6 it breaks, so that must be 3. That gives 14, so that has to be the 7 then. And that fixes a 4, fixes a 6, fixes a 4, fixes a 3. What a puzzle. Yes. What a puzzle that is. That was stunning. I loved that. And this idea, I don't know whether it was there deliberately to just throw in this Fistmafell ring in the middle of it. Wow. Hope you guys enjoyed it. Let me know in the comments. And we'll be back later with another edition of Cracking the Cryptic.